Okay, then let's say let's go.
This is a rocket that is going to be launched in the UK, and they're using hydrogen peroxide as their oxidizer. So it's going to be like a cheaper launcher for the UK, and it's probably going to be the first rocket that will launch out of the UK that's a UK rocket that was not built by the government. And then here, this is a launcher from my home country. There you have a really fancy solution where you can use a balloon to lift their launch vehicle up into the stratosphere, and then they're going to drop it and have it air launched and take it all the way into orbit. And yeah, they have one of the cheapest possible rides to space, hopefully in the future. So they could be like super competitive in the space industry for launching small sats.
Yay!
If you want to add anything.
No, I mean that was brilliant. It was a great job. Yeah, we're also developing really sustainable launch systems by launching at the edge of the atmosphere, so we're not depositing any black into the ozone layer.
And they're also using a hybrid rocket, which is similar to our hybrid rocket a little bit. We both use paraffin wax as our fuel. They're using liquid oxygen, but we're using nitrous oxide.
Very cool. Go Canada, go!
So here we have Rocket Factory Augsburg's rockets, which is going to be a bit of a fancy one. This is one of the 3 German companies that's trying to build a rocket right now. And they have basically a system that's using RP1 and liquid oxygen. And they have kind of a standard design with the 9 engines on the bottom and then 1 engine for the second stage. So it's kind of like a miniature Falcon 9 almost. But unfortunately it won't be recovered. Yeah, they have a factory in Augsburg, and they're trying to develop the entire infrastructure to be able to build these rockets completely in Germany. So, a cool German solution to getting payloads into orbit. This is basically a greenhouse that you can have on orbit, and they can basically spin this thing, and it kind of creates artificial gravity for your plants. Maybe in the future. It's also a good way to manage space in terms of growing things. So instead of having it all laid out in like a bed, you can have it kind of contained in a smaller area, and it works well for rockets because usually we launch tubes and not rectangles. Here we have a drop capsule that actually this goes into the ZARM drop tower, which is here in Bremen. And they basically load this thing into the tower, and they lift it all the way up to the top, and they just drop it in a completely vacuum environment. So that allows them to have zero gravity for 4 or 5 seconds. And they can do cool zero gravity experiments without actually sending something into space. So this is actually I think it's the last experiment that they were just loading into the drop tower a couple weeks ago. I'm not sure exactly what it was or how it works, but it's something to do with how fires start in space. So it's amazing they can do this with just a couple seconds of microgravity.
Wollen wir gleich zur Ariane rüber?
So this is the Vinci Engine, which is the engine that's going to be powering the Ariane 6 vehicle. So this is basically a space engine. So it has such a large nozzle because it's trying to expand all those combustion gases that are happening in the combustion chamber out pressure. And the bigger you make that nozzle, the more efficient it gets. So this is a really, really efficient nozzle that the Ariane 6 really uses. This actually is something that was launched relatively recently. This is the Orion capsule. And you can see here the solar panels that are powering that. And this will basically go on top of the SLS stack, and it's going to be what takes the astronauts to the moon. Here we have Exolaunch's bread and butter. Basically, they're a company that tries to build equipment that you use in order to get things into space. So they make these capsules in which you can put your CubeSats and they'll basically deploy them. But they also make things like the deployment mechanism that pushes your upper part of your spacecraft or the payload off of the second stage of the rocket. So they have this custom designed separation system that is super reliable and just using springs. So there's no explosive charges here, it's just a bunch of springs and magnets. And this is the part. You can see the part, how it works.
I just push these. So I grab this pin and then push these in.
Here we have the Stratos IV rocket. It's a rocket that's been developed by the University of Delft. They have a group called DARE, and they're also trying to build a rocket that goes to space. And this rocket almost made it. It was on the launch pad just about half a year ago. They had some issues with the valve, but it's a at least the real rocket, this is just a model, but it was a fully functional rocket ready to go to space, and definitely some cool rocketry and engineering that went into it. And you can see here that it's also a hybrid rocket. So this part is the oxidizer tank, and this part down here is the combustion chamber. And here's where they have basically a paraffin grain, similar to what our design is. And they're basically going to push the nitrous oxide into the combustion chamber, and that's how the hybrid rocket functions. Yeah, can't talk about the nozzle now, but that's it.
You want to talk about us?
This is our stand. But more on our stuff later. We're going to talk about the other groups first. Here we have another cool rocket group in Germany called WARR. They're not just rockets though, they do other types of space applications as well. And yeah, some of their stuff includes building things that will drive on potentially another planet. They also have a space elevator project. Like I mentioned, they have the rocketry project, and I'm forgetting the other two.
Space labs, so experiments on the ISS, and CubeSats.
I think they have a functional CubeSat, which was launched 4 years ago, which is still working. So incredible space hardware that has lasted well beyond its expected date. In classic NASA form. So here we have another student rocketry group that is working on a rocket which will land itself. They're also having a hybrid rocket, and they want to basically go up about 200 meters and then come back down and land it on those pads that you see, which will come out and be like landing legs. And if they're successful, they will actually be the first student group to land a rocket after it's flown on its legs. Impressive. Which would be pretty cool.
Okay.
And here we have a Swiss student rocketry group called ARIS. They are also developing rockets quite a lot, and they have had many successful launches in the past. They actively compete in a competition called EUROC, and they've designed, I think,
For Europe.
they've designed 3 rockets for EUROC, mostly launching to 9 kilometers. And yeah, here you can see a lot of their engine manufacturing that they have played around with. And you also see their recovery piece, which is actually quite innovative because they're going to, one of their recovery systems actually steers itself back to its launch point or to any designated point they choose. Here we have the most interesting stand of the entire fair, which is of course ours. So let me just run you through a couple of things that we're displaying here. So of course on top here we have ASTRA's nose cone. So we wound this out of carbon fiber, and yeah, essentially this will go on top of the vehicle and cover the recovery bay and the avionics package. And then just below here we have the oxidizer tank. The nose cone is going to sit right on top of it, and this is going to be what contains all of the nitrous oxide, and we'll be pushing that into the combustion chamber. And this is made out of carbon fiber and aluminum bulkheads. And then here we have our avionics bay. It kind of looks like this because it needs to be waterproof. It's going to, of course, land in the water in the end, so we want to make sure that all the electronics stay dry so that we don't corrupt our data files and mess up our wires and such. Here we have some 3D models of our propulsion stuff. We don't have actual parts for this yet, but we're looking for them at the fair. Here we have our injector. So you can see it's just a standard shower head design. So oxidizer will come from this side and go in through these holes and be shot out these little tiny holes on the other side. And the holes on the outside are just for bolting them to the bulkhead. And then here we have our nozzle. It's designed to be compartmentalized so that you can take it apart and put it back together again. So this part here is basically the graphite nozzle that we're going to have. And then the rest of it is basically an aluminum retainer ring, which is adapting it to the size of the full-scale CFRP2. And this ring here is just going to be what keeps it all in place. Moving on, we have our 2-stage parachute recovery system. This is the one that just passed its final shock testing and is ready for actual deployment and actual flight. Basically the way this works is that we have a bunch of servos which are holding down lines which keep screws compressed, and so when we actuate these servos it causes the line to lose tension and it shoots the springs out and causes the deployment to happen. So it's completely in-house designed, and we basically 3D printed and used aluminum profiles and put this entire thing together ourselves. We get the 2 plates on the bottom and the top machined by a company called IVT, and otherwise everything else is built by us. Here we have our separation system, and this basically uses a servo mechanism to actuate these gears here, which rotates this plate. And what happens when this plate rotates is that it moves from the locked position here to the unlocked position when these screws reach the holes, and that's what allows the springs inside to activate and push the ring off. And this bulkhead piece here was machined by a company called Aljo, and the ring on top was made, as I said before, by IVT. And then finally we have our bay where all of the electronics reside. So this goes inside of the canister that I was showing you before. And these levels are basically going to be places where we can put all of our components and our batteries and such. And hopefully it'll allow us to have these components surviving the G-forces that they need to in order to get us all the way to the carbon lab. And that's what we've achieved so far. We're going to keep on building. There's lots of stuff to do and lots more stuff to get ready in order to get the rocket ready to launch. And yeah, we hope that you come by and check us out if you haven't already.